So today we are studying about the oscillation. So oscillation have a three type of oscillation we have studied with respect to our syllabus. One is simple harmonic oscillation, next one is damped harmonic oscillation, and third one is forced harmonic oscillation. So today, what is simple harmonic oscillation? First of all, so simple harmonic oscillation means suppose a pendulum is forcefully, the position of the bob is forcefully situated from one position to another position. That means the force is acting to this direction and another the resisting force is acting to the opposite direction. So that means, so when we put some force towards this direction, so obviously the force is become m into d2x by dt square. That means if m is the mass of the body and x is the shifting position, so that means a is defined as the d2x by dt2. This is the instantaneous acceleration. So mass into acceleration is become the force, as well as we have another force that resisted this bob to moving towards this direction. That means F is proportional to the shifting position. It is proportional to the x actually, and it is directed to the opposite direction of the induced force, or externally you induce some force, the F. Obviously this another force, the resisting force is it's produced in the opposite direction. So obviously the minus sign is become that, because this is minus because the direction is opposite. So now F is equal to minus kx, where k is proportionality constant. Clear? So obviously the force in equilibrium, in the equilibrium, obviously m d2x by dt2 is equal to minus kx, or d2x by dt2 m obviously plus kx equal to 0, or d2x by dt2 plus k by m x equal to 0, whereas d2x by dt2 plus omega square x equal to 0. We rewrite omega square is equal to k by m. Okay, we just put it here. Omega square is equal to k by m. Is it clear? Okay, now so this one d2x dt2 plus omega square x equal to 0. This is the equation for the simple harmonic oscillation, whereas x is a position, t is defined as the time, omega is actually defined as a omega equal to root under k by x. This is actually defined as a angular frequency. Okay, this is the angular frequency. It is defined as a root under k by x. Okay, now the solution of this equation is obviously x is equal to a cos omega t plus b sin omega t. We have already calculating this second order differential equation. Obviously this solution of this second order differential equation become this type obviously. So now for the solution of this equation we choose and let a is equal to a sin theta and b is equal to a cos theta. Okay, now x is equal to a sin theta cos omega t plus a cos theta sin omega t. Now or sorry a is equal to sin theta cos omega t plus cos theta sin omega t. We can rewrite this equation like that, a sin omega t plus theta. Is it clear? It is coming from the sin a plus b. This means sin a cos b plus cos a sin b. Clear? Is it clear? This is coming from this equation. Okay, so this one is the solution of the simple harmonic oscillator, where is a is the amplitude, omega is the angular frequency, t is the corresponding time, x is the position of this body of the x is the position of that body which vibrating with respect along with the simple it is follow the simple harmonic oscillation. Which bodies follow the simple harmonic variation? The position of this body, omega is the frequency of this body, a is the amplitude, t is the corresponding time obviously, and theta is the phase angle. Okay, now we choose an angle from this one. This is the constant value. Obviously phase angle is also a constant, that's why theta is become a constant. Theta is known as phase and small a is known as amplitude. Clear? So from this solution what we get? We get simple 2 point from characteristics from the excuse me, some problem is here. So let's start. Excuse me. So we already get the position of the that oscillator. Okay, x equal to a sin omega t plus theta. If you want to calculate the velocity of this body, obviously velocity, so obviously we write this velocity is in term of u. Obviously this is become dx dt. Is it clear? It is become dx dt. So d dt over a sin omega t plus theta. So this is become a omega a cos omega t plus theta. Clear? So we rewrite omega a root under 1 minus sine square omega t plus theta, because Sine square theta plus cos square theta is equal to 1. This is coming from this one. So obviously omega is equal to, write a square minus, we put the a in between the root. Okay, sine square omega t plus theta. Clear? Is it clear? So omega is equal to a square. Now this one coming from this one, a sine omega t is equal to x, we can rewrite x square. So this is the velocity in term of x. Clear? So this is the velocity in term of x. If you want to try to calculate the acceleration obviously du dt, obviously d2x dt2, that means d2 by dx dt2 excuse me. If you try to calculate the acceleration of this equation, obviously it becomes dx dt2. So x is a sine omega t plus theta. This is coming from a omega square sine omega t plus theta. So minus a omega square, and sine, we know that x is equal to a sine omega t plus theta. So sine omega t plus theta is equal to x by a. So we rewrite x by a here. So a is cancel out, minus x omega square. So this is known as the acceleration of the simple harmonic oscillator. Is it clear? I have already calculated the velocity acceleration. Now we try to calculate the time period. Excuse me. Now time period. We all know that. Now time period. What is time period? Time period obviously defined as a t is equal to 2 pi by omega. Is it clear? That because when a oscillation, a simple harmonic oscillation, it is completed at a full cycle, because this is a 180 degree, this is the another half cycle, it is covering the 360 degree. Obviously this is covering the 360. Obviously from the covering the oblique, this is the pi angle, this is another pi angle, this is for the covering of the 2 pi angle, how much time is travel that particle. This is known as the time period, because 2 pi, actually omega is defined as a 2 pi by t. This is the total angle covered by this simple harmonic oscillation, is the corresponding time for the covering of the 2 pi angle. This is the angular velocity. So from this equation we can rewrite t is equal to 2 pi by omega. So obviously 2 pi, and we already have root under k by m. Is it clear? We getting from the, when we try to reduce the simple harmonic oscillation, we getting this term omega is equal to root under k by omega. Now we put this one is here, m by k. So t is equal to 2 pi m by k. This is the time period of the corresponding simple harmonic oscillator. Clear? So you have already calculated the acceleration, velocity, acceleration, time period. So now we try to calculate the energy. Now let's calculate the energy. Energy of the SHM, simple harmonic oscillator. Is it clear? So we have instantaneous velocity. What is that? The instantaneous velocity of SHM equal to is U is equal to A omega cos omega t plus theta. Clear? So obviously the kinetic energy equal to half m u square. So we can rewrite half m a square omega square cos square omega t plus theta. This is the kinetic energy. Write this carefully. Kinetic energy equal to half m a square omega square cos square omega t plus theta. This is the kinetic energy. Okay. Now we try to calculate the potential energy. So what is potential energy? The shift at the what is what is potential energy? Potential energy is nothing but a changing of the position of the body, changing of the shape of the body. Then the potential energy is generated. So now when we try to shift a bob from this initial position to another position, obviously we change the position. So this is the position change from, so suppose this is the position, shifting position is x. Suppose this shifting position is x, then the potential energy is written as 0 to x, obviously f of dx. This is the potential energy. Okay, so obviously 0 to x, so f is defined as a kx, because this is the restoring force. This is the resistive force or restoring force. When you put some force towards some direction for the moving of the body, another resisting or restoring force is generated to the opposite direction due to the, obviously, Newton's third law. Every action has a equal and opposite reaction. This is coming from this one. So this is become kx dx. So this is known as the half kx square. This is the potential energy of the body. Now the total energy, put the value of the kinetic energy and the potential energy. Kinetic energy plus potential energy, we get half a square m omega square cos square omega t plus theta plus half k x square. Okay, half m a square omega square cos square omega t plus theta. Can rewrite this one like that. K is equal to a square sine square omega t plus theta, because we know that x is equal to a sine omega t plus theta. We know that already, this one. So from this one, half a square, getting the half a square is in common. So obviously it is become m omega square cos square omega t plus theta of k sin square omega t plus theta. Clear? Half a square k cos square omega t plus theta plus k sin square omega t plus theta. How could we rewrite this? M omega square is equal to k, because we all know that omega square is equal to k by m. So obviously m omega square is equal to k. We're getting from this one. Okay. So half a square k is equal to cos square omega t plus theta plus sin square omega t plus theta. So this is become 1. So obviously half k a square. This is known as the total energy of the simple harmonic oscillator. It is clear for everyone? So today we are study what is that? We study what is simple harmonic oscillation. What is simple harmonic oscillation? What we are studying? What is simple harmonic oscillator? So simple harmonic oscillation is mean that the oscillation of the particle moving back the forth about this equilibrium position through the restoring force. Suppose you put some forces towards some direction through this body, and this body is become to its initial position by through its restoring force or resistive force. Restoring force, actually restoring force, it is generated to the Newton's third law, because you put some forces to the some direction, another force is obviously generated in a opposite direction. This force is known as restoring force. So first of all we have to calculate. Let's summarize. Just we put some external force through a body. This is the restoring force. It is also, where is my pen? Excuse me, I get it. Oh, it is also example of this one. Suppose you get us this is a body, you fixed it with a spring is here, you put some force towards this direction, obviously